Okay, good morning, class. Wow, we only have 16. I guess you guys are busy with, I don't know, still have more midterms. So anyway, so we still have a couple of minutes. Let me take questions if you have any questions related to the lab or anything else before we start. Yeah, go ahead, Aman.
Can you hear me?
Sure, yeah.
Yeah. So basically, I wanted to ask, I was thinking about this. Like we've discussed that Java doesn't have dynamic memory allocation, right?
Um,
So,
Saying it in that way, well, okay, let's say the following. Java doesn't allow you to control the memory allocation directly,
okay.
right? I guess that's the better way.
So,
But yes, go ahead.
yeah.
Let's see
So I
what.
was thinking like in large scale programs, like now that you reworded it, it kind of makes sense. But I was wondering like if you can control the memory in large based programs, how do you ensure that the Java based programs are efficient in terms of memory usage?
Yeah, that's an excellent point, Aman. Thank you so much for that. Really, garbage collector. So as I said before, the component of the Java virtual machine that is responsible for uh, cleaning the memory for you to be efficient. Because what you mean by efficient, I'm interpreting this as, for example, if you don't use something for some time, you might be overloading your memory, not deleting it, and then, well, you are not memory efficient or space efficient. So what I want to say is the component responsible for this in the GVM is called garbage collector, and building effective garbage collectors is one of the areas that is active in software engineering. There are multiple methods, multiple algorithms, and really there are even conferences and journals that are specifically for that. But something to mention is that the Java garbage collector is really an effective one, right? So simply you can build big, large scale projects using Java without worrying about if you don't use a certain memory location for some time, that it will accumulate and then makes your program exceeds the memory or behaves badly or this kind of thing, or slows down your machine. That's one thing. Then the other thing is, if you are talking from the speed point of view, one of the main advantages of C and C++ is speed. Uh, and this is why C is almost the, I would say, the dominant programming language in all embedded system applications, and even high performance ones, the ones that would require very low latency. C is a winning one. This includes self-driving cars. This also includes really many operating systems that you might not imagine. Uh, if I recall, for example, Windows was based on C Sharp, which is also a version of C, an advanced version of C by Microsoft. Linux is a kind of also C-based. This because the factor of speed in the C programming language. Um, Also, machine learning applications. I said self-driving cars. Well, most of you might imagine that machine learning applications are heavily Python based, right? If I ask every one of you what is the language that is associated in your mind with machine learning, you might say Python, right? That's correct from the interface point of view. So basically, as a machine learning user, you would have tons of Python libraries to interact with the machine learning algorithm, like TensorFlow or PyTorch or all the common mostly used library. But if you look into those libraries in the heart, they are really implemented using C, right? Why? Because of speed as well. You want to accelerate stuff. Um, so this is with regard to efficiency. So every language has its own advantages and disadvantages. The good thing about Java, it's not very slow. It's not like Python. It's not an interpreted language. So it's quick. The other thing is really it's integratable in the sense that you can put it in any operating system using GVM, and almost now any, I would say, medium scale operating system or domain would be supporting GVM anyway. So you don't need to recompile your code and do these things. And also it's very close to C, right? In C, well, more bugs might be expected from the project because again, you have the fine-grained control in the memory, but responsibility comes at a cost. So human errors are very common in large-scale C programs, while Java takes away some of this responsibility, and then that means it's more resilient, I would say, or less human error prone, right? I know it might be a detailed discussion, but it's a good one, and I like the question. Thanks, Aman. I hope I kind of give you some context. There is no one clear answer for this, right? It's just a matter of how you see the programming languages and what are the advantages and disadvantages, right? Ishmam, how come Lab 4 marks got taken down? Oh, is that? I should check that. Let me see. Maybe Salah or myself, while was working on other things, we made it unvisual or something. But I guess it should be out since yesterday. So I will check this, Ishmam. Thank you. Okay, so if we're already 10:34. So so let's start. What I want to do today is to kind of give you some practice. The good thing is, well, we are done with Lab 5 tutorial. So as usual, we will look into some practice questions to make sure we understand the lecture. So those questions that or those kind of practice examples that I don't have time in the lecture to discuss, I like to discuss them in the tutorial. One of the things we heavily discussed in the previous 3-4 lectures is inheritance and polymorphism. And the good thing about this is also it includes the classes and composition, all the things we also had since the beginning of Java. So it's like a quick revision for the whole Java part of the course. So this is a question from the last offering final exam. And let's see how to kind of interpret or apply the knowledge we know from the lecture into this question. So simply you are given some classes. So here, so let me use the pen. So simply the first one is you have a class that is called cup, right? Oh, draw. You have a class that is called cup. And as you can see, this, once you see that a reserved word extends, you know that inheritance is playing a role here, right? And then you have a second class that is called bell, a third class that is called jar, and then a fourth class that is called box. So these are the 4 classes you are given in this example. Since you have inheritance and seems that some of them are inheriting box, others are inheriting bell, it might be a very good practice to really visualize this inheritance. So first of all, I have cup. So cup is inheriting box, right? So I draw something like this. And then I see bell, no one is inheriting bell, so I leave it for now. Then jar is also inheriting box. So I would have jar here, right? That means box is the parent for both cup and jar. And then I see that box is inheriting bell. Here comes, that seems bell is the grandparent, right? Let me make sure I mute everyone to avoid. Okay, good. And then we have bell as the grandparent, right? So by just having this visualization, it will help you understand the relationships, right? So, and this is in fact a very good, I would say, advice on approaching the exam. You need to organize your thoughts. So I always say the following, and maybe this is something outside the context of the programming. Final or midterm exam management is really something on its own that you should work on, independent of the course, right? Some people are very good at managing the exam, like they know how to organize themselves, they know how to deal with the time stress in the exam, and then they do better, even if their technical knowledge is really not as, for example, good or maybe not better than others, right? So the exam final grades are not only a factor in your technical knowledge, they are also a factor of your kind of, I would say, some skills related to how to manage yourself inside the exam. So listen carefully to the tips I'm giving here, because I believe this will help you kind of relieve some of the stress, organize the information you get from the question, and hence it will facilitate you answering this question. Good. And then we have some variables that are kind of seem like objects of these classes, right? And then we have a table that simply calls some methods. And what we want to do is we want to see what is the output of, let me see, in the following indicate the right-hand column output, and 3 lines output with A followed by B. Yeah, so simply, we want to bring the output of each of these method calls, right? You don't necessarily have a single output. You might have multiple outputs, as we would see right now. So let's see what we have. First of all, let's start with the first part. I have var1.method2. So let's say what is var1. Here, var1 is of reference box, and the memory object is box. So the second kind of management skill that you are looking at is, for each question, you should identify 2 things we mentioned in the lecture. So does anyone know what are these 2 things that are related especially to inheritance, to help you kind of demystify the inheritance questions? What should I look for in any object variable? Reference and object type, Katie, thanks. So you have the object in the memory, and then you have the reference into it. By knowing these 2, and you know the rules you should apply for inheritance, you are done with such kind of, some people will kind of see this is a tricky question, but as far as you know the rules, it's very straightforward. So the first one is pretty easy because the reference and the object of the same type. We said that's the simplest thing. You shouldn't even care about inheritance now, right? So var1 is of type box. So if I'm calling method 2, let's go to the box class, this one, and I'm calling method 2. So what does method 2 print? It just prints box 2, right? So your output for this one is straightforward. They just box 2, right? So I guess that's straightforward, that's clear. That's not even an application of inheritance. It's an application of just normal class object with calling an instance method. Good. Okay, yeah, thanks also for those who, Cham and Yolanda, thanks everyone. And then var2.method2. So let's see what is var2. var2 has a reference. Now we start the inheritance kind of game, right? var2 is a reference bill, but it's of object jar. So let's see. So here, our object is jar, and our reference is bill, right? And I'm calling here also method 2, right? So what should happen? We first should look into method 2, into the jar class. So method 2 in the jar class. What is jar class? Yeah, here. Method 2, first of all, is not a static method. Do we have any static methods here? No, right? So you shouldn't care about the static things. So we are only dealing with instance methods, right? So what is the rule? If you have, first of all, what is the relationship between jar and bill? Well, basically jar, here I use my figure, jar is a child of box, which is a child of bill, which means also jar is inheriting bill by default, right? That means if you have something of reference parent that is pointing to an object child, and this is an instance method, what matters? So what is the rule we have here? Yeah, override, but which one applies, right? So should I consider the method at the child or the method at the parent? Child object, use the parent method, child method, override parent method. Yes, so this, like the general rule, so Abigail, no, we are not going to use the parent method. So the general rule for an instance method is you always use the method of the object type, right? So if the object is child, then you use the child, right? And I guess we kind of have seen this with the examples in last lecture and the lecture before. So in this case, you are using the jar method. And in jar, method 2 is printing jar 2. So you just have jar 2. Good. Then variable 3. So again, what is the rule here? I always look into the object type. var 3 is of box type and cup type. Again, the same relationship between parent and child. I should look into the object which is of cup type. In the cup, method 2 is printing cup 2, right? But here, not only that, the method didn't finish yet. So I'm also calling the super.method2. So what is the super of the cup class? What is a super? When I say super.method2, which class I'm referring to? Box, that's correct, because super is your parent and your parent is the box. That means after printing cup2, I should go to the box and print method 2 of the box, which is here printing box 2. So what you would have is something like, so var3 was what? var3 was cup. So I'm printing cup2, and then another line, I have box 2. Is that clear? So why this is printing two things? Because the method in the child is also calling the method in the parent here, right? I was at the cup and here. So you are printing two things. This is also an application of the super, right? Is there any question related to this? So you see how we apply the knowledge, like the theoretical knowledge we know, to see what you get from a certain code snippet, right? Okay, so what do we have else? So we have var4.method2. So in var4 is jar box. So jar is the child. So I go to the jar. Jar here is printing just jar2. So that's simple, right? So let's look into something that might be, so these things are kind of similar, right? So let's then jump to something that have casting, because that might be the second interesting part, right? Here we have cub var1.method1. So we should first of all distill this. We should understand what does it mean. What is the type of var1? var1 is of box type, right? So I have var1 of box type, but I'm casting this into cub. What does it mean? So if I do something like this, if I do, this is my var1, and then I do cub, then var1, and then equal new box. So how should I approach this? Well, you should follow exactly the same strategy. You should ask yourself, what is the reference type, and what is the, so no, I just did something bad. This should be dot, which method we are calling is method 1. I should ask myself exactly the same questions that I had before. First of all, var1 is your reference of type box, but you did a casting. So what is the reference type? Sorry, what is the reference type? That's correct. What is the reference type? It's cup, right? Perfect. So if I do, so this is completely equivalent if you have a variable of type cup, and then you say dot method 1. So what happens in this case? You inherit methods from cup, Sarah. So let's think, because this might be tricky. Again, the best way to approach this and to avoid any confusion is to follow the same strategy by saying, I should know what is my reference and what is my object. First of all, does this change the object by any mean? If you do the casting, you only do the casting for the reference, right? So your object of variable 1 is still the thing that you allocated in the memory, is still of type box, right? Then you casted this one, var1 from box. Now it becomes cub. So now we kind of inverted the relationship. We have an object of type parent, and we have a child pointing into it. What do you think of that? Not allowed, right? This is basically what we discussed, right? So no, yeah, that's basically what we kind of discussed in the inheritance lecture. Is once you define your reference, you define your object, you know what are the rules. So now once we visualized it, you guys were confused, but once you saw it in front of you, knowing who is the reference, who is the object, you kind of retrieve the rule, which is a child reference cannot point to a parent object because, well, that's not allowed, right? Good. So the second question is, this is not allowed. Does this give you a syntax error or does it give you a runtime error? What is the difference? A syntax error is something that is happening statically at the compile. Remember in Eclipse, you do build first, which is the compilation process, and then you do run, right? So the question is, do you get an error through the building or the compilation, or do you the runtime? Runtime. Well, so when I have one that is a syntax error and one that is at runtime, do you remember? Yeah, so Mark, that's exactly my question. Is this a syntax error or it's not a syntax error and it's runtime one, right? What do you think? Any idea? So the rule we said is it's always that the child, so basically a child object is of parent type, but a parent object is not of child type, right? So we said if you do something, so let me open the example we had in the lecture to connect this with the lecture. I guess it was in this one. Was this one? So until this opens, so what we said is, so simply the inheritance is a relationship, but this is a relationship between the child and the parent, which means any object of the child type is also of parent type, but not the other way around. If you forget this, visualize, like think of the practical examples. Not all horses, so basically all horses are mammals, but not all mammals are horses, right? Then if you cast, it's opened, let me share with you. No, I want to remember which one is that. Yeah, here. Let me share this one. So here. So we said there are two situations, one that gives you a syntax error, the second one is giving you a runtime error. The one that gives you a syntax error is the one when you try to assign a reference of the type child, which is in this, I hope you are able to see the slides, right? So a reference of type child to, so if I go screen here, the one that is syntax error, this is your reference, which is of child type, the circle one in our lecture, right? While the object you are assigning here is of parent type. So assigning object of parent to a reference of child, that's a syntax error, right? That's not allowed. While if you cast, which means I'm casting all this reference thing into some sort of a reference, a child reference, and then assigning it to my child, well, that's not a syntax error because simply you are assigning overall, this is a reference of type child, circle. This is also a reference of type circle. So there is no problem here, but the whole problem comes from the fact that you cannot make the object of type parent is pointing, so the reference of type child is pointing to the object of type parent, right? Is that clear? Oh no, Yolanda, it's not about explicit or implicit. It's about that if you don't cast from a reference parent to a reference child, that's a syntax error because you are assigning one type to another type that is not allowed, right? While if you try to make the reference of type child and the object of type parent, that's the runtime error because now the reference is pointing to a certain object of different type. That's not allowed, right? But if we go back to our example, cub is a child of what? So cub is a child of box, right? Originally, you would think that, well, a child also has access to all the parent methods, right? That's correct. So I can simply call a method from the parent to a child object. The problem here is we don't have a child object, right? That's the big deal. So if you guys are kind of confused, simply okay, maybe I explain it to you in a different way to make it more sense. So object creation, this should be the, I would say, the essential question. Object creation, does this happen during the compile time or during runtime? So when things get really allocated in the memory, what do you think? Runtime, exactly. So I only allocate the objects in the memory at runtime, which means the JVM or the Java virtual machine will not be able to detect such, I would say, male relationship or bad relationship between that a reference of type child and an object of type parent until you go to the runtime, right? So that's basically the problem. This is a runtime issue because simply the hardware will create for you an object of type parent. Oh, it finds that you are trying to assign a child reference into that parent. We have a problem here. So it gives you a runtime error. Good. Questions? Because I don't know if that's confusing enough. You even cast it, still gonna somehow get, and yes, Yanhao, and that was the whole point in the lecture. It's not about casting the reference. It's simply, you should look at the end. What is your reference type and what is your object type? If object is a parent, it's not allowed at all to have a reference of type child because this is not a correct relationship. Not all horses are mammals, but not all mammals are horses. So you cannot make a horse reference pointing to a mammal object. Good. Questions? So during tutorials, we have more time for questions and remove confusion because we are not in a hurry. I'm not interested in finishing all of this, guys, to you while you don't understand it, right? We already have the theory. So I'm more relaxed to take more questions and make sure you don't get, you don't have a confusion, right? Yeah.
A quick question.
Go ahead, Arjun.
So in the lesson, we talk about casting the object.
Yep.
Right?
Oh, we don't cast the object. That's an excellent point. Okay. So here, when we do this casting, are we casting the object? So casting always happens between types, right? Between variables, which means they happen only between references, right?
So you can't actually cast an object. You're only ever casting the reference.
Yep, object is just created in the memory. It's a physical thing. It cannot be casted, right? You just simply cast the encapsulation of it, which is its reference, right?
Okay, so then could you do circle and brackets in front of C3? No,
But C3 is already circle, right?
Yeah, okay. So I guess where my confusion then stems from, if you go back to the test, is like casting on the left versus right of the equal sign.
Or in, so I guess
Yeah.
here, so
Yeah.
so
Okay.
here there
So
is no equal sign, right? Are you
casting.
referring? Sorry, go ahead. What is, so here it's more of I'm casting a certain reference before pointing to a certain method into it, right?
Right. So you can only ever cast references. You
Correct.
can't cast the object itself.
Yeah, the object will not change in the memory, all right? This is something physical that you don't change.
Right. Okay. I understand.
Perfect. Thanks, Arjun. Other questions? Sarah, so if you want to an object of type child to use a method of type parent, how would you do this since you can cast it? So, okay, so Sarah, you are saying, so let me take your question, use the same methodology that I want to kind of convey to you that you always have to use. What you are saying is, I have an object of type child. Good. Then you have a method of the parent, like the method at the parent, where the child is inheriting, and you want to access it. Well, you always can access this, right? We said before, child is inheriting all the methods that the parent has, right? So that's completely fine. There is no problem with this, right? You don't even need to cast. The child by default has access to all the instance method of the parent, right? Even if it doesn't implement it. But the problem here is not that this is a parent method. The problem here is the object itself was of parent type, and you are trying to reference it using a child type, right? So what is different between the problem and your question is that you already had an object of type child. The question had an object of type parent. If this was an object of type child, we would really have no problem at all, right? Is that clear? I guess this other way around that you are referring to, we will see it. You mean the other way around, which is the object of type parent, okay? If you have an object of type parent, your only way of dealing with this object is to have a reference of type parent. That's basically the rule, right? Yeah, you will not cast it, you will do nothing. It's basically you have to have a reference of type parent, and this is how you can access it, right? Good. How you would access a method from a bell? Well, you either have an object of type bell, or you have an object of any of the childs, and you will be able to access it. So so bell. If you have an object of type bell, you have to have a reference of type bell. So do we have that here? Bell var new jar, bell var new bell. So this is an example of a straightforward relationship where in var6, both the object and the reference are of type bell. So we access all the methods of bell, fine, there is no inheritance. Or if you have any object of any other child, even here, for example, I have a box child, but box by default extends bell. So I have access, by the way, to all the methods of bell. So if bell had a method that is called, let's say, for example, I define a bell method that is called, I don't know, my bell method, right? Here I can say var1 dot my bell method, right? Why? Because this is an instance method of the parent, and this is a child object which has access to all the methods of the parent, right? So the only problem we have is if you have a parent object and you are trying to use a child reference for that. That's the only problem. Everything else is fine, right?
Sorry, can I just clarify my question quickly?
Sure.
So I was referring to the example where we had cup, and in cup it called the super method.
Yep.
So that called a method in box. Let's
Yep.
say we wanted to call a method from pill instead. How would we do that, like within cup?
Within cup, you don't have a direct I'm not sure, to be honest, if you can use super.super. So something like this, because we know that Bill is a parent of box. So can we use super.super dot method? My understanding thinks that this might be allowed because simply super is returning to you an object of your parent, which is box, and inside the box you can really have super.method, but I'm not sure, so I need to check this and get back to you. But my question to you is why you want to do that? Why you want to call a method of the grandparent inside your class itself, not even in the main or in the test like what we do here, right? Because the difference between these things and this implementation is this is inside the class implementation, right? I might need or I might want to access a method of my direct parent, but I don't see an implementation, or I would say a use case of why I might need to access a method of my grandparent or parent, like, because that's like a far relationship. Another way that is I know for sure you can do it is inside your box. If in method 2 you have something like super.method2, let's take this example. This will also help you. If I have something like this, and now I'm calling the cub example, like the one that we had in box var3 new cub, this thing. So I have an object of type cub, right? And I'm calling method 2. What happens when you call this method 2? First of all, you would print cub2, correct? Then the second line is you're printing super.method2. So I have to visit the method in my parent, which is this one. First of all, it's going to print, not this one, I'm calling about the box. Sorry, that's in the wrong place. Be super method 2. So then I'm calling this method 2 in my parent because of the super. This takes me here. And then I'm going to print box 2. So the second line would be box 2. But then this method itself didn't finish. It also calls the parent, which is Bell. And Bell here is going to print Bell 2. So this can be a result of just a single call to method 2 in the cub. If in the box you have a call to the super, right? And that's, I would say, a better factorization or a better good of modular way of writing the code. If you want to call your grandparent, you have to go through your parent first, right? Does this make sense to you?
Yeah, that makes sense. Thank you.
Okay, thanks, Sarah. I guess there was another question here. Cham, for the previous example, when cub called super method, it accesses the method of the box. How do we access a method from Bell? I guess that's exactly the same question as Sarah then. Arjun, how would a reference of parent casted to child look again? Can we review what that does in this example? A reference of parent casted to child. Okay, so if I have something like this, so I guess we have already an application of that here. So let's because this question was trying to capture all these tracks. So let's pick one of these that Arjun is referring to. I have a parent, and this parent is trying to get casted to, yeah, the second example that we have here. var2 is of type Bell, but then I cast it to jar, right? So let's see what happens here. Oh, but even the first one was that, right? The first one was exactly that. It was var. So this var was of type box, but then I casted it to cub, right? Right? Then this also var2 jar would be the same thing because var2 is Bell, but then you cast it to jar. So you have a reference of type jar, which is child, but then var2, oh, now it makes a difference. Okay, that's good. So let's take this one. I'm just going to write it down here to put it beside the var2 definition. So I'm casting jar var2, and then I'm calling method 1. Let's see what is the difference between this one and the previous example. Again, how would I approach it? I would first of all see who is my object and who is the reference. First of all, what is the object here in var2? What is the object type? Is jar, right? So I have jar. Thanks, Ola and Yolanda. And then now what would be my new reference? First of all, it was var2, which was bill, but then I casted it to be jar. So what would be my new reference then? Also jar, right? So now doing this is just the simplest thing. A reference and object of the same type, which means I want to access method 1 of the jar class, right? Method 1 of the jar class is just printing jar1, right? And we are done. So in this example, I'm just printing jar1. Why this one give me an error? Why this one give me an error while not this one? Because again, I'm always doing the same thing. I'm looking into the object and the reference. Here, object reference the same thing. Previously, the object was box, but the reference was cup, and that's not allowed. Arjun, does this clarify your last point? Always look into the object and the reference and decide based on this. Object reference, same type, perfect, no problem. Object is child, parent or reference is parent, that's also allowed. The only problem happens if your object is parent and your reference is child. That's not allowed. I hope these three cases explains to you the situation. Let me pick one. So this was the first case, which is reference child pointing to a parent object. And we said, well, that's not allowed, right? While second case, this one is like the simplest one, both are of the same type, so that's fine. Let's look into something of the third case, which is the object is child and the reference is parent, right? So let's pick one of these that might do this. var3 is cup, and then I'm also casting this to cup, so it's similar to the first one, the second one, sorry. And then var4 is jar, and then I'm casting this to cup. I will leave this for now and I revisit it later. var4 is jar, and then I'm casting it to cup again. var4 is jar, and I'm casting it to jar, so it's similar to what we have done. var5 is box, and I'm casting it to box, so I have no problem. var5 is box, I'm casting it to bell. Yeah, that's the one that I'm looking for. So let's see what is happening here. So what I'm doing, again, let me write it into, or beside this one. So this was var5. I'm casting this to be bell. And then var5, and then dot method 3. Good. So how would I approach it? Exactly the same way. Ask yourself, what is the object type? So first of all, what is the object type of var5? It's box, right? It's box, thanks. Yeah, so box. So I have a box here. And then what would be my reference type? First of all, the reference was of object. If you remember from our last lecture, object was the parent of everyone. So if you go back to our visualization here, well, I have object here, right? So originally it was of object type, but then I casted it to bell. So that means now the new reference is of type bell, right? Which is this one. What is the relationship between bell and box? I go back to my chart. I find box is child of bell, which means I have the third case here, which is your child, sorry, your object is child, your reference is parent. Is this allowed? Yes, it's allowed. But how this is different than if your object was parent? Even if a reference of type parent can point to an object of type child, we said there is one constraint during the lecture. Does anyone remember? If you have a reference of type parent that is pointing to a child, does it have access to all the methods of this object? We have coded this on online GDB, right? Do you remember? No, right? Yolanda, thanks. Only if it's inherited. Only if it's inherited. But Mark, this is a child, which means it inherits everything by default, right? Or I guess you are referring to the methods that were originally in the parent and are inherited by the child. I guess this is what you wanted to say. So basically, inside the child, you have two types of methods. The ones you inherited, right? And the ones you implemented yourself. So these are child specific. If the reference of type parent, no, not necessarily marked, like it's simply assume even I didn't override them, but simply this is a child object which has these two, but a parent reference only have access to the first type, which are the ones that were originally in the parent, right? So if I do something like this, in this example, let's see, we said this is reference. Here I have 5, this was box, and this was Bill, right? So now I'm trying to access method 3. Let's see where is method 3. Well, box doesn't have, so where is box? Box, it has method 3, but Bill doesn't have method 3. That means method 3 is only for the child, not for the parent, which means what? So if I go to slides, I want to visualize this. I don't want to get confused. Discard, and then I might share this thing, new slide, and then that. So here is the point. I have this child, let me make it big, box. This box implements some methods. Method 2 is one of them, and method 3 is one of them. While this box is a child of a parent, Bill, that let's say it only has method 2 and it doesn't have method 3, which means this one is inherited and overridden from the parent, while this one is only specific to the box. Now, for this, let me change color. For this object in memory, I created a reference of type Bill, right, which is the parent. The rule we said in the lecture is if your reference of type parent, it only has access to the methods that are inherited from the parent. Methods that are specific to the object are not accessible by the parent reference, right? Which means if you do something like, let's say you cast Bill, in our example, var5 dot method 3, this is an error. What would be the error you get is simply Bill doesn't have a method called method 3. Does this clarify? Yes, Arjun, that's exactly correct. It cannot access method 3. Yeah, and Aki, I guess that's the reason why it cannot access method 3. So then how would I be able to access method 3 if I want, right? You simply need a reference of the child type. So going back to the rules we mentioned, which I guess it's good to connect with, let me have another empty slide here. Oh, well, I already discarded, so that's. So we said we have now three general cases based on the reference. Say do this, reference and object. First one is same, whether it's parent or child, really there is no inheritance here. So the object and the reference are of the same type. Everything is allowed, no inheritance, no problem. Second case is reference is of type child, object is of type parent. Well, that's not allowed no matter what, right? Third thing is your reference of type parent. Maybe I have this as 2 check marks. and then object is of type child. This is the last case we have looked at. First of all, is this allowed? What do you think? Yes, it's allowed, but what is the rule? Is this the same as 1? No, it's allowed, but let's have it as a single check mark, not 2, because there is one caveat here, which is only access parent methods, right? So this is simply the summary for all the mess we have been discussing since the beginning of the tutorial and the last 2 lectures, right? Is that clear?
I have a kind of follow-up question to that.
Sure, go ahead, Arjun.
What happens if you have an overridden method in the child that is the same as, you know what I mean? Like in the example we were just doing, box has method 2, but pill also has method 2.
Yeah.
So if you have a parent reference,
yeah,
referencing a child object, but it's method 2, that method exists in both
in the parent, which one,
child.
which one you call? Yeah. So in not in the last lecture, in Tuesday lecture, we had, I would say, a trick in the lecture that was exactly that the one that you are saying, and I asked such question. I waited for a minute, but then it turned out not as everyone always almost imagined, right? So if you remember this was exactly the trick you are asking about, Arjun, if you were in the lecture. So let's exemplify this just also as a revision for everyone. Simply what Arjun is saying is, well, assume I have a child, it has method 2, while its parent also has method 2, but this one is overwritten because it implements it in the child. And now I have a reference of type parent. Am I calling method 2 from the child or calling method 2 from the parent? Does anyone have a hint here? What might be the answer for this? Method 2 from the child. That's correct, Ola and Sarah, thanks, and Ike. So so you call the method from the child even if the reference of type parent. Why that's the case? Because this method is overridden. So once you have your object of the type child, method 2 of the child takes the priority over the method 2 of the parent. Why that's the case? We also said another clear reason for this is always in instance methods are dependent on the object, right? That might be, I would say, another note here as a summary. In instance, remember when we discussed in instance methods versus static methods, we said in instance methods always depend on object, right? Not your reference type. So if your object is of type child, it overrides the parent one, you always pick the child one, right? While in static method, it's different. Your static method, and we had some examples about this in static, like I guess Tuesday lecture, if I remember. So in static method, it's the other way around. Static method always depends on the reference, not the object. Does this answer your question, Arjun?
Yeah, so this is, I guess, then where the power of overriding comes in, because
correct.
you can have a more general type that can be assigned to multiple different things, but because of the overriding, you can access very specific methods.
Exactly, that's correct.
Okay.
That's exactly correct. Jan, how can you do super.method 2 to access parent? Yes, but you can only use super inside the class itself, not in the main or in the testing, right? So super is only used like this, which is inside a class, right? Let me go back here. How much time do we have left? Oh, we're already over. That's bad. Let me see if there is any. So I guess we went all through the cases. Just one final thing, I guess it's only 1 minute or a couple of minutes, is assume I have something like this. Let's pick a one that is representative here. So I want something of type cup, which is var3, or what is var4? var4 is jar, that's fine as well. Yeah, here. Assume I do something like that. What is that? Let's put it side by side again and check what I mean by that. var4 here, I do casting to var4. Oh no, that's a jar. I don't want the jar. I want the cup. Yeah, I want this one. So assume I do something like this. After defining var4, I cast it to cup, and then var4 dot, well, which method is that? It's method 1. What do you think of that? This is the last thing we kind of we discussed. It might be clear, but I just wanted to make sure you guys get it. So what is happening here? How would I approach this? Well, exactly the same systematic way, right? What is object? What is reference? First of all, what is object? Jar, Yolanda, thanks. Yeah, so I have jar here. Then what is reference? Originally var4 was box, but now it is cup. Well, what is different here? Jar is a child of box, but what is the relationship between cup and jar? Well, I have to go back to my drawing. What is the relationship between jar and cup? So I have, this is jar, this is cup. No relation at all, exactly. So now, simply it's not an inheritance relationship. Between two childs of the same parent, there is no relation at all, right? Which means I'm using a reference of a certain type to refer to an object of completely another type. What do you think of this? Syntax error, right? That's not allowed, right? That's something you cannot do, right? So again, this is another reason why kind of understanding the relationship between classes will help you answer the question. So what you should do for this, for inheritance questions in general, two things. First of all, draw this relationship between different classes. Second thing is identify always what is your object and what is your reference. By doing these two things, remembering the rules, you will simply be able to solve any inheritance problem, right? In an interview, in an exam, while coding, it doesn't really matter, right? The final thing that I want to mention, let's say, but isn't jar can be seen as an instance of cup? No and how, not at all, right? These two things are completely separate classes, right? They don't have any relationship, correct? So childs of the same parent have no relationship at all, and that's important, right? So the last thing I want to mention, because there was a question back then that I didn't answer, I wanted to keep to the end, which is, well, will we have this kind of questions in the exam? The purpose of this tutorial wasn't to kind of exercise for the exam. It was rather to make sure you can apply the knowledge and make sure you understand the knowledge we had in the lectures. You might get it, you might not get it exactly in the same format. For example, I don't give you something and I ask you what is the output. That might be the case, but you would still need to apply inheritance in other format, writing a code, fixing an error. For example, I might give you a program that has something like this, such a bug we discussed, and then you resolve it. So I was more focusing on applying the knowledge to make sure you get it. How would the exam looks like? As I posted on the announcement, not yet Arjun, but then like in yesterday, I posted an announcement on 2SH Avenue page. Simply, we have, I guess, like 3 review lectures or something like this, and during these ones we might go through the format of the exam. The only thing we know for now for the format of the exam is it's 2/3 Java, 1/3 C. Most probably we are going to use not most, it's like 99% we are using GitHub for this as well. I'm exploring ways to connect GitHub itself with an online compiler such that if you don't want to go through the hassle of Eclipse and Git, you might be able to do this. The other thing I mentioned, which might be different from the midterm, is now I'm more lean to allow you write directly into the GitHub web page. So if you don't want to, so simply you can just go to your GitHub repo, do edit, write the code in your browser, and that's it. You don't need to, if you want to do this, if you think that's easier, I'm fine with that as well, right? But how many questions, what are the type of the questions? I didn't put the exam yet, so maybe by next week I should have a better idea. So by this we are done. We are already over time, but I can take few questions, and thanks everyone. I hope this was useful.
I just have one question.
Sure.
Say you have a parent reference and the object is of type child.
Good.
But the child and the parent do not have the same method. So there's a method called method 2 in child and method 1 in parent.
Good.
So method overriding will not happen then, will it?
Correct. There is no method overriding, that's correct, but inheritance still applies, which means the child would still have access to method 1. Excuse me. So if you write something like this, so that's a good example. So let's go back here. Well, I guess I have to discard and go back again. Okay, where is that? So here, so your parent has method 1. Your child has method 2. Let me put it down. And then this is child, this is parent. You created an object of type child. And I guess your question is saying I had now a reference of type parent, correct?
Mm-hmm.
Then let's call this reference something like var reference, or like, let's call it just var. And we know that's type is of type parent, okay? And that's the child. Can you do var dot method 1? What do you think?
Yes.
Yes. Why that's the case while the child doesn't have method 1?
Because it inherits it from the parent.
Exactly. Right. So that means now you can do it, and the one that is going to run, because there is no overriding, it's the one at the parent. That's correct. Can I do something like var dot method 2?
Yeah. Wait, no, because it's referencing
Exactly.
the parent object.
Method 2 is specific for the child,
Right.
which means the parent cannot access it. That's not allowed. Does this answer your question?
Yep. Perfect. Thank you.
Yeah, perfect. Thanks. Any other questions? Yolanda, I have a question why Bell 2 was called at the top example where there is cup 2, box 2, Bell 2. That's super. Let me go back to this. No, I just, yeah, no. Okay, Yolanda, so we have done this as an example if you add super dot method 2 here at the box, right? That's not part of the original question. This was a question that we modified to answer Sarah's question is, what if I want to call something from the bell? So what I said is, well, if you want to do this, you need to add the super dot method 2 at the box, right? So originally, this one is not printing bell 2 as part of it. It's only printing cup 2, box 2, right? Is that clear? Okay, yeah. Okay, so thanks everyone, and I guess I will hopefully see you all in 1 hour during the lecture. Bye-bye.